All right, we're going to start shortly, so please join us on todaysmeet.com/perlascience136. Let us know you're here, and we'll begin once we have all classes ready to go. All right, so we've just about got everyone with us, so we'll start shortly. We're just waiting for Miss Taylor's class to make sure that she's with us. Okay, and we'll be ready to start. Okay, you're doing it wrong. Give it to someone else. Alright, if you're not able to get it up in the next minute or so, just go ahead and put it on the back table. Okay? Alright, so Ms. Taylor's class is going to be joining us shortly, so we'll go ahead and get started. But yesterday we were looking at what property of magnets? What property of magnets were we looking at yesterday? Permanent? What does that mean?
It means that it's always...
Okay. True. Okay, we did look at the fact that the magnets are always magnets. That doesn't change. Does it ever stop being a magnet? Okay. Now, we noticed that magnets interact with certain items. What item does magnet interact with, Thomas?
Iron.
It interacts with iron. Okay. Today, however, we're going to look at something a little bit differently. Because there's something really interesting that happens when you bring two magnets together. Okay, we want to find out what magnets do when you bring them next to each other. Okay, the word that we're going to use is interact. Okay, so that is investigation for today. So go to your table of contents and title it Magnets Interact. So go ahead and update your table of contents, get it into your next blank section. So for me, that happens to be page 11. And we're going to be looking at the interaction between magnets. So any ideas as to what the focus question might be for today? All right, time's up here. Unless you're there, put it on the table. So if you're not there, set it on the table. Okay. Any ideas as to what the focus question might be? I think it'd be pretty obvious.
How do magnets interact?
Yeah, there you go. Pretty obvious if that's the thing that we're going to be looking at. So the focus question is, what happens when two or more magnets interact? What happens when two or more magnets interact? What is the definition of interact? How do I define the word interact? I have to know what it means if I'm going to be figuring out what happens when they interact. What does it mean when things interact?
Like when they interact, like when they like touch each other.
Touch each other?
Well, not.
Come together.
Yeah.
They don't have to touch. Just come close to each other. You interact with each other all the time. You interact with each other every day. Doesn't mean you're touching each other every day. You're just together. You come together. You come to school and we interact at school. So interaction simply means when you enter, which means to come together, and then act, which is what you do. So what do you do when you're with others is what interact means. So when two or more magnets interact, meaning when they come in proximity to one another, what happens? What do? Does anything happen? Okay? So go ahead and get that into your list or your table of contents there. Okay. Now, you should have, in your classroom, you should have your stacks of magnets like this. Okay? So what we're going to do now is we're going to take these magnets and we're going to get them to you so that you can start to kind of explore and see what happens when these magnets interact. Okay? Now, I'm only going to give you one magnet. So how are you going to get these magnets to interact with each other? Leah? You're going to have to interact with each other. Okay? And interact with each other does not mean, Jackson, give me your magnet so I can see what happens. No, it means let's come together, let's work together, and see what happens when we get more than one magnet close to each other. So work with the people around you. Okay? You can work with one person, you can work with two people, you can work with three people. It's entirely up to you. Okay? So if you are getter one from your table, come on up and collect magnets for the number of people that are in your group. So let me know how many people are in your group and I will get you the magnets you need.
5, 4, 5.
Perfect. Okay, once you have your magnets, I want you to work in partners, groups, or however you want to do it to actually start seeing what happens when these magnets interact with one another.
What was that called? He meant the entire. Wait, it's gonna fly. I'm gonna make it fly. Wait, alright, fine.
So if you have like a they should all have IVs.
No, wait, I'm gonna make it.
And I think they did. I think they
How do they create that? It's true. I can make it look
Oh, let's take a look.
Oh, wait, you have to get that.
Very interesting.
I tried to put it Let's make it.
Oh yeah, we already know that. The negative was pushing the positive. I want to touch it also. I got it on the table.
Now it's your turn. Now it's your turn. You put it on, you have to put it in the each other now make it go zoom.
That was actually mine.
I know, but look.
Put it. No, it's hard. Do you know what it's doing? Not putting it under the table.
Wait, I was going to do this.
Now let me control your head. Now
Jason,
one side.
I got it for that.
You want to see? Put your hand on.
This is awesome. You gotta do this. This is awesome. Yeah, do it like this.
I put a curse on this magic ring.
Lower your voice, Vincent. Go back to your group.
Put a curse on this ring.
No, wait, no.
What did you guys find out?
That's what we did.
So what does that?
The
Testing. 1, 2, 3.
No, that's covered in magic. Let's cover it in
I heard Haley.
Wait, no, he has to.
Let's try to make a triangle.
No playing around.
I almost got it. You got it?
Oh no! Okay, I get it. Wait, flip it on and then pull it off. That's like. Put it back on the paper. I'm testing it. No, you're not.
Watch this. No.
It's holding 2 letters. The magnets are supposed to interact.
I made mini
I know. Okay, now pull it off and see what happens. No, not mine. No, not like that. No, like now only pull this piece off like that.
Let's see if they interact like
Not like that. Maybe it's too unstable. Alright. If that boy does it while he's off in the air and hits me. No, that's not what I said. Let me see the magnet.
oh, it's still close.
I call this.
I think it's hers, because it sounds like yeah, it sounds like Amos Taylor's class. I think it's hers. Okay.
No, look. What if we move it slightly? This is not work, but we move it just
Give me. Wait, what is this? Okay. That was crazy. Look. Okay, we're gonna do
it's a better way to do it.
wait, guys. Oh no, I didn't try that. I didn't try that. Hold it.
It's just because
Lorraine. Last time I got it, it was a trash can. You guys Yes, look that. Yeah,
Not now. We're going to talk about it in a second.
yeah. Here, I'll show you.
wait, actually,
Okay, it was more colorful.
alright, let's
Oh my goodness, there's a magnet and Coke.
Hang on, let me I can't see that. I want to try something out.
My book has metal.
All right, ladies and gentlemen, hands on your heads. 5, 4, 3, 2, and 1. All right, it's time to kind of talk now about the discoveries that we made. So all magnets should be at the center of your table. No one should be touching them. Okay? If you have a magnet in your possession, you will no longer be able to use the magnets for the rest of the investigation. So, self-control. Okay? All right, so what are some things that you observed? Kaylee?
Magnets have iron in it because they stick together.
The magnets have iron in it because they stick together. Okay, that's interesting. Now we know magnets stick to iron. Okay, but does iron stick to each other?
No. Yes. No.
Do two metal things stick to each other?
Yeah.
No.
No, they do not. So, is it the iron that makes it stick to stuff?
No, it's the magnet.
No. So, just because a magnet sticks to it, does that mean it has iron in it?
No.
No, there's something about a magnet that interacts with iron, but it's not the iron that makes it stick to other stuff, because that means then that two metal things should stick to each other, and they don't. Okay? So, in fact, I would probably tell you these are what we call ceramic magnets. They don't have iron in them, but there's something special about them. So, what else did you discover?
With the magnets, when you have the same poles and you're trying to stick them together, it's like there's a little tiny invisible ball in them and you can't stick them together.
Okay? So, when you bring two magnets together in a certain direction, they don't stick to each other. They tend to push each other away, which is kind of odd. Okay? What else?
Well, the other thing that I discovered, not only if you put magnets together on a piece of paper it will stick, but if you pull the one magnet off really fast, the other one will go flying in that direction.
Okay, so you're saying when you put them between a piece of paper?
Yeah.
So when you put a piece of paper between them, what happens?
They stick, but when you pull one of the magnets off really fast, the other one kind of goes flying in that direction.
Well, that's just because you're pulling it, right? That would be if I pulled you. So that has nothing to do with the interaction of the magnets. That just has to do with the way you're using them.
I also discovered that for some reason when you try to push the magnets together, they won't go. But when you put the side of the magnet on the table leg, it sticks.
So when you take a magnet and you try to attach it to something made of metal, does it matter which side you're using?
No.
No. You can use either side and it's going to stick, no matter what. However, if you take that and another magnet, and you try to get them to stick together, it does matter which direction the magnets are facing. So let me give you an example. Okay, so we're going to go over to the desk cam here. So if I have a washer here, I can take a magnet in this direction, and it sticks to it. I can take the magnet and flip it, and it still sticks to it. So it doesn't really matter which side of the magnet I use, it's going to stick. Okay? Now, if I take a magnet, and I take this magnet and I put it here, it sticks to it. However, if I take the same magnet and I flip it over, and I try to stick it to it, it won't stick. It will push it away. It doesn't want to stick to that side. Okay, so let me get that washer out of the way. Okay, you're going to notice it doesn't want anything to do with that. Okay, and so it actually goes away, and it wants to stick to the side. It won't allow me to stick the magnets like this. I can do it this way, and they'll stick fine. If I flip it, they won't go. No matter what I do, it's gonna push it away, and it's gonna want to stick to the side. It would rather do this, okay, than stick the wrong way. Okay. What else did you discover, Vincent?
I discovered I read this in my physics.
No. I don't want to know what you read. I want to know what you experienced. Science is about experience, not about reading. Celeste.
If you put one magnet and you put one on the top,
So that's very interesting. Okay, so we know that the magnets have this weird attraction to each other. And objects don't seem to stop it, do they? In fact, if I put a piece of paper in between the two magnets, if I take this magnet and put it here, and I put this on top, it really does not make a difference. If I move the bottom magnet, it moves the top one. Which means that the interaction between these two magnets, can it go through stuff? Okay, it can go through a piece of paper. Okay, if you had an opportunity to put the magnet here, okay, and I'm going to try to get here under the table. Okay, I could come under the table, and depending on how thick the table is, you might still be able to get an interaction. Okay, if you don't, then maybe you just need a stronger magnet. Okay, so I'm going to take a stronger magnet that I have here. Okay, and you'll see that I can create an interaction with magnets through the bottom of the table. Okay, so one thing you discovered that's pretty interesting and it's really important is that the interaction between magnets can go through stuff. Okay, the table doesn't stop it. And if you had magnets that were strong enough, the door wouldn't stop it. Okay? So that's pretty interesting because when you start to think about technology, okay, we have technology where we use magnets that talk to each other, they interact with each other, and when you stick a human body in between them, the human body doesn't stop it, but yet we can detect what happens and we can take pictures of what's happening through the body using magnets. Okay? It's called an MRI machine, a magnetic resonance imaging. Okay? And so understanding that the interaction between magnets can go through things, you can do pretty cool things with that. You can put a human body in between, and the magnetism goes right through the person, but as the magnetism goes through the person, that magnetism interacts with your cells, and your cells react a certain way, and the magnets can pick up those interactions and put them on a computer screen. The computer interprets it and draws an image, makes a picture of what it's actually seeing. Okay? So that's really cool uses of technology. Anything else that you discovered?
You know how the magnet, certain parts of the magnet don't stick together? If you lay one on the table, you could kind of push the other around with it.
Okay, so kind of what we did here. Right, I could set it here, and since I know that they don't want to interact with each other, if I do the wrong side, it's gonna push it away. Right, so I can make the one magnet move without touching it by using that interaction. What's the last thing, Ramson?
It's actually a question.
Okay, right now we're just talking about things you observed.
Okay?
Sit down.
Something similar to what you said earlier, Jackson put two magnets and they were like pushing it like against them and they just didn't want to stick on a pencil.
That's really interesting. Okay, I'm glad you brought that up because it's really cool. Okay, so I'm gonna sit here in front of Jason here so you guys can see it. So I've got a pencil here, and if I were to take these two magnets that are stuck to each other and stick them on a pencil, it really doesn't do a whole lot, right? Because you're like, duh, that's pretty obvious. Now, what would happen if these two magnets couldn't get away from each other and I flipped them?
They would.
Okay, if I flipped it, they're not going to want to be with each other. Okay, and you're going to discover something pretty interesting. I can take these two magnets, let the top one go, and it'll float. It'll float because it does not want to touch the other one. Now, if I were to add another magnet to this little representation, okay, you have this scenario where the magnets don't want to be next to each other, but there's nowhere for them to go. The pencil is keeping them from going anywhere. So, add a fourth one. So I'm going to give you a second in your groups to kind of experiment with this. Take your magnets, put them together on a pencil if you didn't do this already, and feel that. Take your magnets, listen up. Hands on your heads, 5, 4, 3, 2, 1. Once you've done this and you've created this, okay, give everyone the opportunity to then take the top magnet and push it down into all of them. And you're actually going to feel that there's a force that's pushing it back up, which is really odd because there's nothing there. Okay, there really is nothing there, but yet you can feel something is pushing it. Okay, all right, go.
Nope, doesn't work. Okay, I wonder if this will work. Hold on.
What group are you with? Yes, Hakeem, do you have a magnet?
Yeah. Still on that one. Nope, that's it.
Okay, now mine.
Put it on the table. Put it on the table.
No. What if we Tyler tears the Tyler put it on the top? No, he didn't. Okay. Put it on the table. Okay, we have one on the table.
Wait, good.
I'll be right back.
Somebody lost it.
See what's happening.
You guys want to do an announcement? How you want to put together the entire show. You guys can do all of that. You guys want to make a video or something? If you want to create your own video, that's fine. If you want me to help you guys come up with something, download it. It's up to you, however you want to do it.
We launched a magnet in space. I know. We did.
So one thing you could do is
That's awesome. You guys look at this.
and then we can when you're ready to count. So what you can do is shoot me an email and let me know who you need, and then we'll make sure that we're announcing it.
Okay,
Nice job, that's nice, Kara.
Eureka!
All right, hands on your heads. 5, 4, 3, 2, and 1. So magnets are back in the center of your table. So I got you. You can see there some interesting points that people have made on today's meet, things that they discovered. Okay, so it's like a magnetic globe that floats. The magnets were dragged by pulling under the table. Okay, so there's a lot of things that you can see. Okay. Now I want to show you something that's pretty cool. Okay, it's probably something you did not discover on your own. But if you take a magnet, you can actually have it do something pretty darn cool. Okay, I'm going to show you. Okay, so I'm going to take a book here, put a piece of paper on the book. I'm going to try to angle this so you can get a pretty good look at it. Maybe I'll turn on the lights so you can see. Okay. But if I take one magnet and I set it here, like this, and I take a second magnet and set it here, okay, if I'm holding them the wrong way, they're going to want to attach to each other. But if I do it just right to where they're apart and they push each other, okay, what you will see is that one of the magnets is what? Okay, one of the magnets is actually floating. Okay, and if I tip it,
magnet is using the force.
okay, you will actually see the magnet is actually floating in the air. Now I don't have, let me grab a light so you guys can see it a little bit better.
Use the force.
So let me take this flashlight. And we'll use this flashlight. I have to rip this. Sophia, can you give me a pair of scissors?
Darth Vader is my favorite.
Okay, now,
Can I go this way? This.
And those 3 batteries? No.
alright,
Oh, yeah. Sorry.
so Rohan, you are done with science. Ramson, do you have magnets in your hand?
No.
Who else has magnets in their hands? Anyone that has magnets in their possession right now is done with science. So, if there was anyone in your group that was playing with magnets right now, you're watching the rest of the time. Okay, so what I'm going to do is I'm going to turn on this flashlight so you can actually take a pretty good look and you can see better. Right now it's in the shadow, so it's kind of hard to see. But I'm going to give you an opportunity to try this on your own. Okay, so you should be able to get a better look when I show you like this. You'll actually see that one of the magnets is in fact floating in the air. Okay, so let's see if I can maybe if I can. No. Let's see. Let's try to light it up right there. But you can actually see if I tap on it. Okay, this is what we call the talking magnet because it looks like a little mouth kind of moving. Okay, so what you have is the magnet actually floating in the air because of the force. Mr. Perla's room. Sure. Okay, bye. Miss Aubrey, I need you in the office. Okay. Okay, so you'll notice that the 2 magnets are far apart from each other, and I slowly start to take one of them angled, and I start to kind of drop it, and eventually you'll notice that if you get close enough, one of them actually will not want to fall. It'll stay. And if you do it just right, at the right distance, you'll get this interaction here. Okay? It helps if you do it on a piece of paper, do it on a notebook, so you have friction between the magnet. Okay? And eventually, if you don't do it right, that is what will happen. They will pull each other. Okay, so you want to do it far enough. Here, if I drop it, it'll fall. So that's not close enough. So there, if I do it here, it falls. So I want to get a little closer. Okay, and then I can just tap it. And again, if you do it on paper, it's easier because you have friction between the two magnets. If you do it on the table, they slide too easy. Okay, so I'm going to give you, I don't know, about 4 minutes to experiment with this. See if you can get it to do it.
Them 2 get to do it with me.
Oh yeah. Magnet Vader.
Remember, you want to use paper. It's going to help. So try it on someone's notebook.
You and Raiden. Watch Raiden.
Can't do it.
Come on, we have to make Magnet
You're too close. You want to be farther apart.
We have to make Magnet Vader.
You have to be on
You watch me do it.
Magnet Vader. Magnet Vader.
So Sophia, did anybody else accomplish it here yet?
A negative or fighting each other.
Anyone else accomplish it here?
How'd Sophia do it? I just keep it. Yeah, since like half.
Okay, Come on.
You've got this.
Got it! I got it!
It's hard.
On my stop. Yeah. Give it. Stop tapping it. Letting it go. You guys got it?
Yep.
Yeah, you're using the wrong thing.
Guys, we got it! What's up? Yay!
Hey, he's talking.
No, it's Magnet Vader killing him. Magnet Vader killing him. Magnet Yay, we got it! We actually got it! Oh, no. Yeah, that was ruined. Yeah! That was
Okay.
I can do it. Talking data.
Now, the side does matter. If you start to do it and they start to pull to each other, then it's the wrong side. You've got to flip one of them. Okay, now, which side did I use? I can't tell you which side I used because the magnet isn't labeled. Okay, so that means that as you're doing this, you're going to have to play around with the sides. If you notice that no matter, every time I do it, it pulls, then I probably need to flip one of the magnets so I can get that interaction. And then continue to try it. Okay, this is something that is going to take a lot of practice. Right now, I've got 2 students in my class that are able to do it. For the rest of you, it's just one of those where you just need to practice because it does take a while to get it to interact. Okay? All right, magnets, back to the center of the table. And let's come back to our notebook. Okay, now, so the things that you discovered were that magnets interact with each other. There's a lot of pulling that goes on, and there's a lot of pushing that goes on. Okay? Pulling and pushing are not the scientific words for it. Okay? So let's make sure that we know what the scientific language is. So I would say when magnets come together, okay, so just kind of keep up with me. When magnets come together so they pull and stick, we call that attraction. Okay? We say the magnets are attracting. Okay, and you say, never heard that word before. Have any of you never heard the word attract? You've heard it a lot. Okay, where do you think the word attractive comes from? You go, oh, that girl, she's really attractive. So when it's a word that's kind of like magnetics. When magnets come together and they pull and they stick, you are pulled by something. You say you are being attracted. Okay, attraction. Okay, and so when you're talking and you see that girl walking down the hallway, or you see that boy in gym, you know, making every basket, and you're sitting there and go, man, that's so attractive. Right? Why attractive? Why that word? Because it's almost as if you're being pulled to them. You're being attracted by them. It's like you just can't stop. Your eyes can't stop looking. Okay, in our classrooms, I see that sometimes. I see, you know, Sedona's eyes keep getting pulled in one direction. And I go, why do they keep getting pulled to that one boy? Oh, she must be attracted to him. Okay, so think of words. Think of maybe how we've used them. Attraction means to pull together, to bring together. Okay, that's what happens with magnets. Now, there is another one that is also used. Okay, and we would say that when magnets come together so that they what? They push apart. We don't call that attraction. We call that repulsion. Okay? And I'll give you the shorter version. We say they attract, and down here we say they repel. And you go repel, repel. I've heard that word.
Yeah.
Insect repellent. How many of you guys have ever heard of that?
Yeah.
So think it's the same word from repulsion, repel. So when you think of magnets and what they do, they repel. Well, what does that spray do to the insects? It repels. It keeps them away from you. So when they come close, they're like, ooh, they get pushed away. They don't like it. So they are repelled by it. Okay? Right? Repulsion. Another word, repulsive. How many of you guys have ever heard the word repulsive? Seth, what does that mean?
It means like gross.
Gross.
Like get away from me.
Yeah, get away from me. You're sitting at your science table, and Aubrey goes, I don't feel so good. And I said, you want to go to the nurse? No, I'm fine. And then 2 seconds later, blah, all over the table. Okay? You find that extremely repulsive. Everyone runs. Woo! It's like magnets. They push apart. Okay? And no one wants to be around Aubrey. Okay? And Aubrey looks at Ramson and goes, I'm sorry, Ramson. And Ramson goes, don't talk to me. Your breath is nasty right now. Right? Repulsion. To repel. Okay? So when you think of these words in science and you're thinking of magnets, think of attraction. Well, what does that mean? Okay? Attraction. If I'm attracted to someone, that means I'm being pulled towards them. If I'm being repulsed by something, that means I'm being pushed away from it. I don't want to be around it. Okay? Repulsion and attraction. Those are the two words that we use in science. Now, why do you think that magnets repel sometimes and attract others? Why is that? Does a magnet think?
No.
Okay, is a magnet like us?
No.
Heck no.
Okay, is it like us where I'll sit there and I go, oh, she's so pretty, and then she calls me a name, ugh, she's ugly now. Right? A magnet doesn't change its mind. Right? It doesn't change its mind. Okay? Sometimes you watch TV and you see these actors and actresses and you go, man, they're so handsome, they're so pretty. And then the paparazzi catches them at Starbucks at 7 in the morning without makeup and you're going, ew. Wow, they look totally different without makeup. Right? And so, does a magnet change its mind? Does it say, oh, I love you? Okay, and is attracted to another one, and then all of a sudden, I don't know, something happens, they get mad, and he goes, oh, I can't stand you. Okay, and then all of a sudden now they are repelled. How does that happen? What happens? What do you think is going on with magnets where sometimes they're attracted, sometimes they're not?
The poles, they have different poles.
Okay, what does that mean?
Like the north and the south pole, they stick together, and when there's the same pole, they just repel each other.
So you think it has something to do with the side. Okay? Okay, so the idea, the theory right now is it has something to do with the side. Okay, so a question I might ask, and I would say, all right, so let's come down here, and I'm going to ask, well, here's a $1 million question, and
You're gonna give us $1 million?
let's make it interesting. Let's do blue. So the question is why? Why does this happen? Okay, and so the idea right now that's out there on the table that Jade pulled, and she goes, it has to do with something, and we'll call it poles, because that's what she called it, and I don't know if that's the real word. We'll have to come back to it. Okay? She said she thinks it has something to do with the sides of the magnet. So if that's true, then that means that each side of the magnet okay, if that's true, then that means there has to be something to do with my magnets where one side does one thing and the other side does another. So the question is, how do I know which is which? How do I know which is which? So if I were to figure out which is north and south on this one, Could I figure out which one's north and south on this one? You think you could? Ramson, what do you think?
I think it's right, actually.
Okay, you're not listening. Okay, so if I take these two sides, they always stick. Now, if I keep doing this all day, will these two sides continue to stick? Will they always stick? Yes. They will always stick. If I flip them both around, okay, and I have magnets that repel, okay, like this. Okay, well here they're sticking. Now if I flip them around like this, they're going to repel. Will they always repel?
Yes.
They will do this all day long. It will never change. And so the question is, well, how do I know which is which? How do I know which one is, I guess we could say side A on this side of the magnet. We'd call this side A, and this one's side B. So if I gave you this magnet and I said, well, which is side A and which is side B, could you figure it out?
Yes.
Okay, so that's kind of what we're going to look at right now. So we know that they have different sides, and so we'll call them side A and side B. Okay, so if I take a side A and I bring it close to a side B, what's going to happen?
They're going to stick.
They're going to stick. If I take two side A's and bring them close together, what's going to happen?
They're going to repel each other.
They're going to repel. Okay, so how do I figure this out? How can I find out which is A and which is B? Any ideas?
You can try to stick them together and see if they'll stick, and if not, then you'll know it's... Oh, yeah.
So if I stick them together like this,
Then you'll know one side.
are those side A or side B?
Hey, just name it a side.
Yeah, I mean, you can't really name it.
Jay?
Get another magnet that has labeled poles.
Get another magnet that has labeled poles? Okay, well, you're on the right track using a third magnet. Okay? You'd have to use a third magnet to figure it out. So the question is, how would I use a third magnet to figure out which is A and which is B? Okay? That's going to be your task.
Uh-oh.
Okay? So, we don't know. Okay, right now, we're assuming, listen up, you are assuming that side A and B attract. Could it be possible that same sides attract?
No.
Okay, let's say that this is A and this is B. A and B, okay, attract. That's what you're saying. But what if this was A and this was A?
Then they wouldn't.
A and A attract. So how do I know that I'm wrong? How do I know that it's opposites that attract? Make sense? So that's really important. So I need everyone to really pay attention. Okay, so here's why. I'm going to take a highlighter.
Okay.
And I'm going to highlight this end right here, and I don't know if you can see that very well. Okay, you can't see it at all. Okay, but I'm going to take a highlighter, and I'm going to say, let's assume that this is side A, and this is side A. So if I bring these together, that means that side A and A attract. Okay, so if these are side A, then that means the back is side B, the back is side B, and if I put B's together, they attract. If I bring them back, if this is A and this is A, then that means if I flip it, this is A and this is now B. If I put A and B together, they repel. So, the question is, do A and B repel?
Yes.
Or do like letters attract? Or do like letters repel? Do opposite letters attract, or do opposite letters repel? Do we know? We don't. So what you need to do is you need to come up with an experiment. How would I figure out which way to do this? So, like I said, Jade was on the right track when she says I need to use a third magnet. Okay, so you're going to use this third magnet, and it's not labeled, but you should be able to figure out, right? You should be able to figure out. You're going to take this one and you're going to label your third magnet. Say, I'm going to call this A and I'm going to call this B. And then I'm going to see what happens. Right? You're going to take this magnet and see what happens to this one. And then label it. And then take another magnet. Play with the other magnet. See what happens. And see if you can use this third magnet to figure out whether A's attract, whether like letters attract, or whether like letters repel. Okay? So, right now, you should have 4 magnets at your tables, or maybe 3 if you've only got a group of 3. But your task is to Try to figure out which side is which for each magnet. Now, I don't have sticky dots, but if you are in Miss Taylor's class or Miss Richards' class, there should be some reference stickers that the kids can use, if you look on here, that they can actually stick on their magnet that they will label. Now, so they're going to go through and they're going to label their magnet based on what they think is happening. So in my class, I'm just going to use masking tape. So if you don't have those dots, you can use masking tape. Okay, but go ahead and spend about 5 to 10 minutes trying to use a third magnet to label 2 other magnets. Okay, so I'm going to go ahead and mute my classroom, and the kids are going to actually start experimenting with this. And if you have any questions, it is on page 173 of the teacher's guide. Okay. But basically, you're going to use one magnet to try to label 2 others, and tell me which side is A and which side is B. Okay. All right. So I'm going to mute us so you guys can keep working. Alright, ladies and gentlemen, let's come back together for a bit. Hands on your heads. 5, 4, 3, 2, and 1. Okay, so we're really struggling as to how this works. Okay, so how do I make sure that this does the same thing? How do I make sure that this works?
I have no clue.
Okay. Do magnets interact in the same way? Do they? Will a magnet change its mind and decide that today I like side B, so I'm going to stick to B today. Tomorrow I might stick to side A. Or will a magnet always stick to the same side?
Always stick to the same side.
A magnet will always stick to the same side. So, let me get you started. Here's, this is really important because I'm sure all the other classrooms did this as well. Okay, you came into science based on assumptions. Assumptions means that you are assuming something is true. And therefore, since I assume it is true, I'm just going to treat it like it's true. And my experiment, my data are going to be messed up because of what I assumed. Okay? There are many of you that assume A and A won't stick. For whatever reason. So what did you do? You took a magnet here and you took another magnet and you said, okay, those two sides, you said, all right, let's see, this side and this side, they don't stick. Therefore, this one and this one are both A. And you labeled them because they don't stick. Okay? What evidence do you have that like sides won't stick? What evidence? What are you basing that on? What are you basing your idea that A and A won't stick?
All sides may be the same.
Is there any evidence that A and A won't stick?
No.
Well, I mean, not really, but sometimes for like maybe like a cell, sometimes like it's usually. Oh yeah, never mind.
Okay? So because these two sides don't stick, you sit and you assume, okay, those two must be A. So you take a sticker, you put it on here, and you say that's an A, and that's an A, and you label it. And you say, okay, I'm going to label this one side A. Let's see, let me find a Sharpie here. I'm going to label this A, and I'm going to label this A, because A's don't stick. And then you say, and then the backs must be B's, because why? Because B's don't stick. And you go, all right, let's take a look. B's don't stick. Now, if I put an A with a B, an A and a B will stick. So you say, all right, I got it. I'm done. But you based all of this off of what?
Assumption.
What assumption?
Assumption that A and A won't
Yeah, you based it on the fact that A and A won't stick and A and B will. Well, how do you know that's right?
You don't.
How do you know that maybe it's A and A that stick and A and B that don't? How do you know which one's right?
You don't.
You don't. So you need to find an experiment that is going to prove to you one way or another. So, how do I do that? Well, you've got to think scientifically. You've got to think and say, well, I assume A and A don't stick. But that's an assumption. I am not going to base my data on an assumption. If it turns out I'm right, hey, that's cool. I'm right. But if it turns out I'm wrong, then I learned something today. Okay? And even if it turns out I am right, not only did I justify and prove I was right, but I found a way to prove that I'm right. And that's even more important. Okay? Because there are some scientists in history that have come up with great ideas, but they couldn't prove it. And people never gave them credit for it. They said, because unless you can prove it, it's pointless. Okay, Albert Einstein and his theories of relativity, some people thought he was crazy at the stuff he came up with. They said, there's no way that's true. There was no technology to prove it, though. However, as technology expanded and technology got better and we started to create pieces of technology to test his theories and ideas, we discovered
He was right.
he was right. And that's why we call him a genius, because he came up with ideas that couldn't be tested, and mathematically he had proven them to be true, but there was no way that we could know until we actually tested it. So, assumptions are okay, but you can't base your proof on assumptions. Now, so how do I do this then? I'm just going to get you started, and then I'm going to give you a few more minutes to finish. I'm going to take this magnet and attach it. Now notice what I do here. Okay, notice what happens to this magnet, the way this magnet attracted the second one, right? Okay, now, so which side of this top magnet, I'm going to say this is the magnet that I want. So notice that this side is facing away, right? Okay, since that side is facing away, I'm just going to call that the side, oops, let's see. Let's do this. I'm going to take a sticker, and I'm going to stick these two, and I'm going to say the side that's facing away is going to be A. Right? And I know that's an A. I mean, how do I know it's A? Well, I could call it B, right? It doesn't matter what I call it. I could call it X. I could call it P. But what does it mean? It just means that that's the side that's facing away from my magnet. Now, if I take a second magnet and I attach it to this magnet, which side is facing away? It's got to be the same as the other magnet, right? If on this magnet, A is away from the magnet, on this magnet, A should also be away from the magnet, because if that's not true, that means what happened to my reference magnet? It means it changed its mind, and now it decided it wanted to stick to something else. Do magnets change their mind? No. So I can label this A. Now, so how do I know that those two sides are right? Because A is away from the sticking side. A is away from the sticking side. Do you see what I'm doing? Does that make sense?
Yes.
Okay, so do I know that those two magnets are labeled right so far? Yes?
Yes. Yeah.
Sure?
Yeah.
Well, some of you are like, well, I guess, I'm not really sure. Okay. If this is A, then what's this side, Jason? B. Okay. So, it doesn't matter how I labeled them. It doesn't matter at all. This is A, and I'm going to call this B. Could I have flipped the stickers? I could. Doesn't matter. So all I know is that B is this magnet. I could care less. I just want to know what's happening to this magnet. So I know that based on this magnet, which side sticks to it? B. Now, when I look at this magnet, when I look at this other magnet, I know that this magnet and this magnet have to be the same. They're both the same kind of magnet, right? So when I do this one, I know that B sticks to this side. So that means if I try another magnet, what side must be the one that sticks to it? Okay? It's got to be the same. It can't be A, because then that means that this magnet here changed its mind, and first it was attracted to B, and now it's attracted to A. Can it do that? No. So, if it's attracted to that side that I called B, when it attracts this magnet, it must also attract the same side. Which, in this case, because I called on the other magnet, I called it a B, what does it have to be on this one? A B. What if I had called it A on the other magnet?
Then the other side would have to be B.
Then this would be an A as well. Now what if I take a third magnet? And I say, okay, let's see which side sticks to this. This side. So what's this?
B.
What is this? This is a B. It's got to be the same as the other ones. What about this one? This side sticks. So what do I call this one? B. Okay, and then this side sticks. What do I call this side? B. So you go through. And so now what I've done is I've labeled my magnet based on this one. I said the B's stick to it and the A's don't. Now, is this an A or a B? I don't know. Does that make sense? I still don't know. But I know that this is going to be a B and this is going to be a B. And I don't know. Maybe this is an A and the A and the B stick. Maybe this is a B and the B's and the B's stick. I don't know. But what I do know is that these two magnets are labeled correctly, right? Does that make sense? How many of you saw how I did this? Okay. Do it. Now, listen up. Once your magnets are labeled correctly, now I can start to experiment what happens when A's come together. Using which magnets? Using these. What happens when I take an A and a B and I put them together? What happens when I take an A and I put them together? But now, it's no longer based on assumptions. It is based on fact, evidence. I know these are labeled right. I didn't just say, oh, these two stick, so I'm going to call one A, one B. That's assumption. How do you know it's an A? How do you know it's a B?
You don't.
Okay. Do I know which side is A and B on this one?
Yeah.
Yes, because I proved it using a third magnet. So, these are now labeled correctly. Now I can see what happens when an A and a B come together, what happens when a B and a B come together. So, label your magnets correctly, and then after you've done that, come back and look at the interactions between those magnets you labeled and see what happens. Okay? Go for it. I'm going to give you 5 minutes and we're done.
There's only 2 magnets.
Okay, good. So this is my A. I'm going to let's write it down. Where's the other side?
Well, it's already labeled. So the sticking one is going to be that one. Just want to see which side sticks.
So now that you know that the magnets are labeled right, I can start calculating what happens if your A stuck. What happens stuck to this third. And then see if ours is right. Okay, so you know that that's labeled correctly. Now, you figure out what about B and D?
By seeing what happens to those.
Okay,
So what else?
start to take some notes. What did you learn about the sides? Okay. So you would say that when those magnets they have sides, like sides, they don't attract. Like sides, no. Unlike sides, attract. Good. Have you labeled it right here?
How do you know? That's what you want.
You're still making it an assumption. You haven't shown me that you labeled it. Okay, so let's have someone else who has
this one, that one's for me, and you're sitting at this one.
don't label them based on how they stick.
He didn't.
Okay, you can't lose your reference magnet because then you have to start over. So this side is facing away.
Opposite resist. She says. Yeah, because you're assuming that down.
That's exactly what was
Remember, you can't really tell what
This so that you know how to
this inside is like away. So that one.
I could be outside.
Right here. Because any magnet that I take that away is going to be called
The one that's facing outside.
the back of it once.
Exactly how it works, okay?
There's my A. The back. So now, I know which side A and I know which side B. So now I can start to see what happens when A comes together. Start to experiment.
How'd you guys do?
So B to A6, what about B to A6?
Okay.
Well, argument. Does this make sense?
How do you know?
So now in your notes, you start to take out your notes. And say,
No,
label
you've got to be able to
the
tell me how you know.
And we discovered that unlike sides do what? Like
He said that
sides.
the one that's facing outside is A and the one that's
Figured out here?
No, I didn't
How'd you label it?
So you tell me. How do you know it's an A? It doesn't matter which label. So how do we decide this is an A? What is it? Based on
The
that.
reference magnet shouldn't be labeled. You don't know.
Okay, so show me. Where's the A's at? So the A's are the ones that stick. That's what you're saying, because your A stuck. So put it on that one. I'm just showing you. So the A sticks. So does this A stick? Does that A stick?
Because if I stick a magnet here,
Show me that the A stuck.
okay, you can't change.
Okay, so he's got all the A's
I'm going
sticking
here.
here. And that's fine.
Here. Okay,
You
there we
just have
go.
to make
That
sure
works.
that whatever you decide.
And then on the next one, on the next magnet, I'm going to flip this one and stick it here.
Doesn't have to work.
Don't change
It can be any way you want to do it. You can't change it.
There, it sticks. I'm gonna call the outside one A. Then I'm gonna take
If you wanted to do it where they were all on the
and I'm
outside,
gonna stick it on here.
he's just doing it where they all stick. He's making all the A's stick together. And that works
I'm
too.
gonna call the
As long as
outside
whatever
one
thing you pick stays the
But
same.
it's the outside one on the same side of the reference. I can't go, oh, that's A. Now, let me flip this
But
one.
if you're more comfortable doing it where it's on the outside, do his, see what works, and then
That's like
switch
you
it
say,
to the way it works on the outside.
Alright, go, let's see how fast it runs. 10 seconds, alright,
See if it works the
or
same
so
way.
that's your turn, except on you, we're gonna put a
Just
50
gives you
count
more
back.
hits.
Alright, ready, go. Leah's faster.
So do his, let's see what you come up with, then do it.
Do it. So if you're gonna do this, that's fine, but you can't flip and do the other side of the magnet for the other side. Which is what you did when you said, on this magnet, we're gonna test this side, on this magnet, we're gonna test the other side.
Give me the secret one. Wait,
You have to use this side. So now I got this down, so this is A and this is A. Now we're gonna start to experiment. What happens when A is on one, what happens when B is on one.
that your ball?
How'd you do it? Did it work?
Yeah.
So what did you discover about the magnets? Light versus unlight sites. Alright, good. Okay. Alright. Let's stop for a second. Hands on your heads. 5, 4, 3, 2, and 1. Alright, so we're going to go ahead and close out. This was kind of a longer one. From here on out, they're actually going to get shorter because this was important for us to make sure that we understood this part of magnets. Okay, so here's what happened. I labeled these two magnets. I showed you how I did it. I used a reference magnet to label my two magnets. So there are my two magnets that I labeled A. What I then did is I took these two magnets that I know are labeled correctly, and I said, let's find out what happens when I take two A's and bring them together. So I took this A and this A, brought them together, and they don't stick. I said, that's interesting. Let's see what happens when B's come together. I brought the B's together. They don't stick. I flipped an A and a B. Let's take an A and a B together. They do stick. Let's take the other A and B together, and they do stick. Okay, so now I have evidence to support the claim that I'm going to make. I can come back to my notebook now and say, okay, I can come into this notebook now and I can actually start to take some notes. Okay? I can say I labeled my magnet and found like sides, what? What do like sides do? Nope. What do like sides do? A's and A's, B's and B's. They repel. Like sides repel. Unlike sides did what?
Attract.
Attract. Okay. Now, was this based on assumptions or was this based on scientific evidence? Okay. So this was based on scientific evidence. Okay. Now, the last thing I'm going to have you do is that I'm going to have you take some other magnets that I have. Okay. And I'm going to put these up here so you can see. Now, what did you discover about magnets? What did we discover about magnets? Like sides do what? Repel. Opposite sides or unlike sides do what? Attract. Okay, so I'm going to show you these two magnets here. These two magnets are called bar magnets. Okay? And magnets have what we call poles. There are two poles. One is a north pole, the other one is called a south pole. Okay? Now, I want you to see if you can see that these two magnets have a pole. The pole is on the ends. Now, what happens when I take unlike poles?
They come together.
Okay? They attract. What happens when I take like poles?
They repel.
Okay, it wants nothing to do with the North Pole. Okay, so you'll discover poles, when they're similar, repel. They do not want to be together. Okay? So if I take these two magnets and try to stick them like this, what's going to happen when I let go? What's going to happen to these two magnets when I let go?
They're going to repel.
Okay, let's watch.
Whoa!
What's going to happen to these two magnets if I were to line them up like this?
They're gonna stick.
They're trapped.
Okay? So, opposite poles attract. Like poles do what? Repel. Okay? So, pretty interesting. Okay? Tomorrow we're going to get into the next part. We're going to take one of these magnets. We're going to take several of these magnets. Okay. Well, you know what I mean. We're going to take several of these magnets. And we're going to put them on a string. And we're just going to hang them. Okay? And we're going to see if we can identify a pattern with these magnets. Okay? It'll be pretty cool. In fact, actually, we may actually get to it this afternoon. I'm going to double up on science for the next week. So if Ms. Taylor and Ms. Richards, if you guys are listening, I am totally up for doubling up on science today and for the rest of the next week so we can get through Investigation 5. That's the only way we'll get through Investigation 5. So we'll basically kind of kill the social studies block. But maybe we could look at the second part of this investigation this afternoon. Okay, but the idea would be to take these bar magnets, hang them from a string, take these bar magnets, hang them from a string, and see if we can identify a pattern in our classroom and see if that's coincidence or if there's a reason why they do what they do. Okay? But again, our reasons will always be based on evidence. Our reasons will never be based on, well, that's just what I think is going to happen. Okay? That's an assumption that you can never base your ideas on. Okay? All right. So for now, we're going to go ahead and close out now. In your notebooks, make sure that you notate that magnets have like sides, unlike sides. Unlikes do what?
Retract.
Unlike sides attract, like sides repel, and the names of those sides are north and south poles. Very good. All right. So with that, we're going to go ahead and stop screening for today. Thank you, and hopefully we'll see you this afternoon. All right, bye.
Bye.